Right. So I have already, introduced what is Terraform, but of course, what Terraform has its concepts. Okay, and I want you to pay attention to the terminologies that we are going to see in this, introductory presentation. But most importantly, okay, the hands-on is also going to make things very clear. So let's look at what the Terraform core concept and workflows, state and backends, why remote state matters. We'll talk about this. And of course, we'll look at some practical labs with variables, output, data sources, and local and modules. Everything you see in this last slide is so important, okay? Variables, output, data sources, locals, and modules. This is the backbone of Terraform. Let's go ahead. So, of course, what now? You need to be able to explain what infrastructure as code and what Terraform's roles in modern DevOps, right? Was at the end of Terraform, you should be able to achieve this five. So when you meet in your various chapter, be it in Dubai, wherever we have our chapters, right? You should be able to use this to examine yourself, if you've been able to, yeah. Right what? So right Terraform configuration, providers, resources, variables, locals, and outputs. Now, let me tell you one thing about providers, right? So providers depends on what you are creating. So let's say if you want to create Kubernetes, right? Because when you look at something like, a technology like Kubernetes, right? We have different sources of Kubernetes. So Kubernetes can come from Kubernetes itself, right? And of course, So in that case, we can We can have Kubernetes as a provider. Okay, I'll talk to you about that. Now, if the resource is coming from AWS, therefore AWS is the provider. So that's what we call the provider plugin, right? If we are deploying on GCP or on Google, therefore Google becomes Also becomes the provider. Use Use the core workflow. Init, format, validate, plan, apply, destroy. This is the Terraform workflow, right? So before you do anything, before you create a resource, you must First, you need to init. So you run what command? You run Terraform init, then you format your code or you validate the syntax of the code, and then you plan. Plan is just going to show you what is going to be created, what will be changed, and what will be destroyed. If you are comfortable with the output of the plan, then You can run apply, and apply is actually going to create a resource. When you are done using the resource, you can You can delete. Again, it's so important for you to understand what we call Terraform state. This is the core of Terraform. In most interview projects, you're going to be asked the question, how do you manage a Terraform state in your environment? So there are two types of states. We have the remote backend and we have the local state. So when you run Terraform apply without a remote state, okay, so state is just like the output of the resource that you are creating. Where is it saved? Is it saved on your laptop or is saved, in the cloud? Then of course You also need to learn how to build and consume a simple reusable module. And then Apply basic troubleshooting patterns of provider errors, drift, and state issues. Very, very important. Okay. So like I mentioned earlier, right? Therefore, IaC has advantages, right? The One of the reasons why most companies today, most projects, use Terraform or use infrastructure as code is Is because they want to They want to avoid, inconsistent repeatability in the process. But when we have a source code, we can what? We can use a source code that we use to create maybe a VPC for MTN to what? To create a new one for Orange. So now we just what? We may just need to just change the variables. Now maybe the name of the client previously was MTN, but now it's Orange. We change that, and within seconds we are able to create. So what? Now our infrastructure management becomes consistent across different environments, clients, and products, right? The other thing that comes with IaC, when you hear IaC, what? We're talking about infrastructure as code, right? It what? It because it's a code, it makes it easy for us to versions control and peer review for change. When you hear of review, um, what comes to your mind as opposed to what we have done so far? Let's say what comes when you hear of peer review and versions control. What is that? What is the main process name called? Peer review comes through what? In Git. Thank you so much, Pascal. It what? It comes through pull request, PR, right? That's peer review. Okay, that is peer review. Then we have what? Auditability and traceability, right? Who will change what and when? Because see, when you work for a big company like IBM that is managing, 4,000 servers and counting, right? We want to be able to trace and audit. We want to find out who is changing what. And that's why versions control becomes so important, because once we implement versions control, it becomes very easy for me to know, oh, you know what? Okay, who changed our server from T2 medium to T2 large? Right? So if you don't have a system in place that automatically record this, right? Everybody going to say, no, I didn't do it. Right? Of course, one of the other benefits is to reduce manual errors. Okay, we can do faster provisioning. And of course, the last one is standardization via modules and patterns. Okay. Terraform is the tool chain. Terraform what is used for declarative provisioning of resources. What does this mean? See, when we say declarative, right, this is what we mean. So let's say, for example, you can say what? Let's say you want to create something like EC2. You can say what? You can say what? Instance what? Instance underscore size, right? You can say what? Is equals to T2 dot, okay, medium, okay, like this. You can also say that AWS underscore region, right? Is equals to what? Is equals to US is 1. Now what? So this what? This is what we refer to as declarative, or you can say instance what? Instance underscore count. Okay? You can say what? Is equals to 10. Now what? It means that what? It means that you are telling Terraform to what? To create 10 instances of T2 medium where in US East 1. That's how you interpret that line of code. We're going to see several examples of that nature. Is it clear? Then of course Terraform is also used for multi-cloud. Okay, it's a multi-cloud technology that we can use to create resources in different cloud environments like Azure, GCP, and AWS. And of course, it has a rich provider ecosystem. Plan, apply, lifecycle, enables control change, state enables drift detection, and of course, change tracking. Not a config manager, but of course, complements Ansible and Chef. Now, this is where, what we call technicality comes in here. And I'll tell you this because of my experience in the field. You are often asked what is what? What is the difference between what? Between, okay, Terraform and what? And Ansible, right? And Ansible. Somebody wants to Google search this. Let's ask AI or ask Google, even if you know the answer, you can just answer this question. What is the difference between Ansible and Terraform? Because see, right? Ansible is what? Ansible, okay, is what? It's a configuration management tool, right? Why what? Terraform is what? It's a provisioning or what? Or creation tool. Who can give me an example that distinguishes Terraform from Ansible based on this? Based on this. Who can give us an example based on this one? Who wants to try? No. You cannot say that Terraform builds why Ansible brings to here it configures and servers and stuff. Yep, I think somebody got the ChatGPT answer to that. So what? If you want to give an example, right? Let's say what? Give an example here. Let's say we have what? We have the university what? University of what? Of Lagos, okay? Computer what? Computer lab. Let's say what? Which is virtual lab. Okay? Now, let's say what we want what? So in this case, what? Telephone what? Telephone can what? Can create 2,000 servers at what? At once in what? In less than 1 hour. Okay? That's the first thing. Therefore, what? Terraform creates. But we need to what? We need to what? We need to maybe you what? Install what? Install Microsoft, maybe what? Office or Microsoft what? Office, right? WhatsApp, Telegram, TikTok. Okay. So all of this configuration what? On what? On the 2,000 servers. Therefore, if you want to install anything, we can what? Use what? So Ansible can what? Ansible can install or what? Deploy what? Deploy configs. Okay, to what? To all the 2,000 servers in what? In less than 20 minutes using what? Using Ansible. What does this mean? So when you go to the computer store and you buy a laptop, does laptop comes with any pre-installed configurations? Like maybe it comes with your WhatsApp there already and all of that. You won't have that, right? Mhm. All the additional things to do on your laptop is what is referred to as configurations. Okay, configurations. So Terraform is going to create, but what Terraform cannot install, for example, Jenkins. So a good example, right, is let's say what you have a ticket that needs to create 10 servers for what? For your Jenkins master slave architecture, right? It creates. But at the same time, Terraform is not able to install Java on all the 10 servers. So what are we going to use to configure the servers? We are going to use Ansible. Do you now understand the difference between Ansible and Terraform? And of course, what? Ansible is also an infrastructure as a code tool. Is it clear? Is it clear? Why what? Installing a web application. I hope that you understand that. Okay? Great. Is it clear? Okay, crystal clear. Yeah, because sometimes you go for project what for interviews and they ask this question, what's the difference between Ansible and Terraform? Right. One is with configuration management, and of course, what the other one is just for what for provisional resource. So you can say, for example, I recently had a ticket in my environment where I had to spin up an EKS cluster right? For my dev environment. And of course, that meant that I had to install Kubernetes, install the kubectl, install, all these components. Therefore, what? Terraform was able to create a cluster itself, but what Ansible was used to either deploy the applications or what deploy the configs. That's how you explain these things. It's very easy and very, very, very straightforward, right? That's one thing with me. I cannot teach with slides because I just slide off the slide. Okay, these are what the major concepts in Terraform that you want to know of, right? So you have providers, right? Resources, data sources, state, modules, dependencies, and graph. Okay, very, very important. Please note this down. These are the core concepts, the vocabulary that you will use throughout this lesson or throughout this session, right? So this is our vocabulary. Providers. We have what? See this here? Now, let me show you something because this is so important. I like this introduction. And so if you go to the Terraform website, right? Let's go to what? Terraform. Okay. And this is Terraform here. Okay. You see that? So it's Terraform here. If you go to okay, so I think, yep, wow, this is good. See that? Now we have what? We have the SaaS augmented users, but above all, you can what? You can see the providers. Let's go to features and use cases. Right. So what? Terraform has its different providers. So depending on what you are creating, what you need to, and that provider is what is configured in a file call or in a block called the provider.tf file. Okay, that's good. So we're going to come to this. We're going to see the different Terraform providers. I don't know if you can see it here, but let's see here, for example, okay, it's something. But you can't see it here quite clearly. Right? Can't see it here. But usually what you're going to see it here, we can become a partner. Oh yeah, so this is also where you can also go in for the certifications here as well. This is one set that you should what if you are thinking about backing up a skill, please take what the Terraform certification examination, and it's not going to fail you. I promise you, right? So when you come to resources, see that you can click here and you can see all the other resources. So we have providers. This is the very first block that we define in our source code. Because if you are going to be, deploying resources in, let's say, maybe in the Azure, right? You what? In your provider, you must input Azure. Okay. And then we have resources, manage what? Objects, Terraform creates updates, okay, and destroys another bucket VM component. And then we have what again? Data sources, what? Read only lookups, fresh existing infrastructures for use in config. State. This is very important, right? We have what? The Terraform state is either a local backend or what? Or a remote backend. Then we have modules, right? We have what? The Terraform what? Package, reusable modules packages with input, outputs, and other building blocks. Then we have dependencies graph. Okay, very, very important. And then great. So now this is how a typical Terraform layout is going to look like. Okay. See main.tf, variable.tf what? Output.tf, Terraform.tf versus is optional. Now there is something you're going to understand. Git ignore. Hmm? Hmm. Is there any new persons in this class today? Somebody will join us for the first time? Don't worry, okay? If you are here for the first time, maybe because the link came to your orientation group, it's no big deal because you are going to do all this all over again. But see, let's say what? This is my project, right? So let's say you want to what? From LS here, let's do what? Make directory 00 what? Let's say compute, right? Compute here. Please, you must note this. The what? The Terraform what? File structure. So if you seed into what? 00, you have what? Now you have to define your files. Terraform have, I think it's 4 major files. You have what? Touch what? Touch command is used to create to a touch what? Maybe main what? Main dot tf file. We have what? Output dot tf file. And then what? Dot tf. We have variables dot what? Dot tf file. And I think we have what? Provider what? Dot tf file. And then we have what? Versions dot tf file. These are what? These are the commonest, okay, Terraform files. So your configurations are going to be in either of these files, main.tf, output.tf, provider.tf, and of course what? The versions.tf file. Please pay attention. The most important thing now is going to be what comes in which file? So that's what this slide is explaining. Does it make sense? So now, guess what? Let's talk about the purpose of each file, right? So this what? The main.tf file is going to what? Of course, is going to, contain what? Our providers, resources, and modules, okay? Variable.tf file is going to what? Input interface, type, default, and validation. Output surface what? Values for user or automation. And of course, what? Terraform.tf file provides what? Environment variables values to avoid what? Committing secret. Git ignore, exclude state, crash log, and Terraform. Now, we are going to see this, and some of you are going to face difficulties with this if you ignore this file. The .git ignore file is so important when it comes to Terraform because there is no way you want to commit your what again? You want to what? You want to commit your your Terraform state file to a GitHub repository. That is a disaster, right? Nobody should do that ever. So to avoid that, we add the touch what? Touch the what? Dot git ignore. That's it. This file, if there is anything that you don't want to push to what? To the Git repository, just input in the .git ignore file. So Git is going to ignore it totally. Right? Make sense? Okay, now. So this is what our Terraform workflow. Okay, the what? The standard what? Standard Terraform commands, right? So we have, so let me show you, right? Let me show you, for example, let me ask, let me show you, right? Let me ask ChatGPT to what? Create me what? Create what? Create content for what? For dot what? Dot git ignore file for what? For Terraform. So I want to explain what comes into this file. See that? Very, very important. And we are going to see this. Okay, but what? Please note this because I have faced issue in my first year of work when I was asked, or somebody's asking for break. Thank you. In fact, God bless you. Let's take a break. Yeah, let's take a break. I'm just going to press the class. I will not stop the recording because it's in the process. But let's take a 10 minutes break. You're right. So Terraform has its workflow, and this is it here, right? We have what? You can also call this Terraform commands, right? So these are the commands that we are going to be using, right, manually. But we can also execute these commands through automation, okay, what we call infrastructure pipelines. And so this is the advanced level of Terraform. So yes, of course, no, you can run commands like, what do we have here? So you can do what? You can run, Terraform what? Terraform, okay, in it like this. But these files have no configuration. So of course, what? You won't get anything there. Oh, wow. See that it what? Okay, it says what? Terraform what? Terraform has been successfully initialized. But if I try what? Terraform plan, there's nothing to plan. Why? Because there's nothing in those configuration files, right? Oh, sorry, Terraform what? Terraform plan. See that? There you go. It says what? You're what? No changes, right? You're what? Your infrastructure matches the configuration. How about this one? Terraform what? Terraform, okay? Like this, see that? Terraform format. So let's say we already had configurations. We can format the syntax, and you can see it formats. Then we have what? Terraform apply. Now, depending on what you had configured in these files, you can create different resources like that. So of course, this is what we refer to as the Terraform workflow. You need to understand init is the first command. It initializes the working directory, the providers, and the backends. Okay, make sense? The backends. Okay, and then what? Terraform formats. It does what? It formats the config files to standard style. Then we have Terraform validates. You have, Terraform what again? 1 second here. I'm checking something else. Don't think I'm checking this. I'm checking what's called for that. Don't mind me, okay? So you have what? You have Terraform plan, Terraform what apply, and Terraform destroy. You want to what? Tears down, manage resources, cost, and clean up. Clean. So if you have 1,000 resources and you want to destroy, or you want to what? You want to tear down, you want to delete all the 1,000 resources, okay? Terraform destroy is the command that we are going to execute. Make sense, everyone? Okay. So we have that. Now, let's look at the next slide, okay? Great. So of course, we can have some demo goals. So this is how the main.tf file is going to look like. I'm going to show you how we can create these files using ChatGPT because what? And then the most important thing is how to interpret the files. That's the most important thing because is what? We live at a time when it's no longer how you create things, it's what? How you interpret what you want to create, okay? And then, of course, this is what our demo circle commands, right? So you have all of that. So, yeah, that is okay. Oh, Terraform state, this, sorry, right? Terraform state. This is the most crucial aspect of Terraform. How Terraform manages its state. Okay. So, what Terraform state does is this: is what it maps resources in config to real infrastructure objects. We're going to see this in real time. Stores attributes what needed to plan changes, enables dependency tracking and drift detection, provides what? A source of truth for Terraform operations. What does this mean? Okay. The interview question is, how do you manage the Terraform state file in your environment? Right? Very important. Can somebody just ask ChatGPT or any other chat? Just ask what? Just say, explain Terraform state file to me. Say what? Okay, say I am a banker or I'm an accountant. Explain what? Terraform set file to me. Let's read from there. Let's get it going. 1, 2, 3, go. Okay. Let's go chat that one, and then I'm going to explain what that means. But we are going to see it in real time because, when we practice, we gain more experience, right, and insight into it. So again, what? See, this is why we came forth with the .git ignore file, because what? You don't ever want to commit. Oh, did we? Okay, we'll not copy that one, cross. But see that this is what. So this is the .git ignore file, and of course, what? According to our best practice, never you commit the Terraform state. See this here? If you have this, you run what? A Terraform state, because when you run Terraform init, right? This folder is, and it's a very, very heavy folder. It's that you cannot commit to Git, okay, to GitHub. The same thing with what? This one, the TF state, all of this. You want to what? You want to leave them on your local. It should never, as a matter of security best practice, be committed to Git, okay? So we have that. Sorry, 1 second. What have I not done? Okay. Of course, state what? State may contain what? Sensitive values depending on resource. It says, okay, let's look at this one. It says, in biology, what? We often deal with gap between genetic blueprint and the living organism it produces, right? In the real world of cloud infrastructure, the Terraform what, or the tf.tf state file serves as what? As the bridge between those two states. So think of it using what? The biological analogy, right? No, this one is big. Let's use a different term. Okay, phenotype record, blah, 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 all those ones. No, let's something else. Can somebody come with something more easier? Let me ask this guy. Are you a chemist? Bright. Okay. Are you a biologist? How can you have that one like that now? Okay, you want something biology is first of all is science. You want to confuse somebody. Better we just define our thing the way it is. Because now I'm going to ask you what is genetic, what is blueprint, what is living organism. Let's look at something that you can explain to your grandmother. We let me see more. Okay, great. Let's see. Somebody's laughing. Okay. I don't like this phenotype and genotype thing. It's just to me now that it's complicated. It's confusing my life. Okay, let's get going, right? We'll come back to that. So of course, what? Never you commit TF state to Git, because what? It may contain sensitive data values depending on resource. Okay, a good example is IP addresses, right? You don't want to commit the IP address of your resources to Git. Teams what? Need logging to avoid concurrent apply conflicts. Okay, this is very, very important. We're going to save this. So when we are working on infrastructure and we store our Terraform state in the cloud, right? It helps us avoid concurrent applies. So let's say Terraform wants to create and Pascal is what created at the same time, right? The moment Terraform launches Terraform apply, what happens? The state locks. So on the same project, Pascal cannot create anything until Terraform is done. So this is a locking mechanism that is happening in the back end. Okay. Talk about that is what. So use what? Remote state for collaboration and recovery. Very, very important. And of course, you can see here, Drift, you can do what? Inspect state, Terraform show. Talking about this, we're going to see this, okay? Everything about this, we're going to see it in. So why remote state? Collaboration, okay? Share state for shared infrastructure. Now, if you don't use a remote state, right, the TF state file is going to be saved on your local computer. So Terraform is going to have what? It's going to have the state of the resources what is going to be different on this machine, and NO what is going to have something different because what is all based on the local machines. But if we have remote state, let's say like an S3 bucket, right? We can what? We can all go in there and see, okay, and be able to reconcile what we have in our source code and the actual resources that we have running. So that way we can what? We can easily reconcile both. So some common state what we have AWS, Amazon, S3 plus DynamoDB tables for locking. Azure what? For Azure, we use what? The storage account state plus block list locking. GCP, we have used what? We use the Google what? Cloud storage for the bucket state plus what? Locking via what? External mechanisms. This could be like, maybe you want to use, let's say, an application like Google Authenticator, right? To unlock your state using some kind of code and security mechanisms that can be done or not. So yeah, I'm going to end here for this, introduction. Then we are going to do installations. Okay, let's install Terraform, and then what? We install AWS CLR. Is that? Yeah, exactly. Okay. We're going to do this using Chocolatey, and we are doing it directly on our Windows computer because this is what will be done at work. Okay, you will not create a server in the cloud just to install Terraform. Say I hear. Okay? Therefore, what? Terraform is a tool that you're going to need to install directly on your computer. Say I hear. Do you hear me? Is it clear? Type 1 for I hear. Okay? So what? We have to install this on. Somebody say I hear. Therefore, what? We need to install this directly on our system. So let's get that going then, okay?